We're going to start chapter 5. Chapter 5 is about exponents and polynomials. So today we're going to start working our polynomial math. The chapter starts on page 341. So we're going to start just by working our ideas, our terminology. So we're going to start with the concept of a term, something that we learned from previous lessons. So we know that a term is the basic unit of an algebraic expression, and we can write a term by just having a variable. This is the variable, also known as the base, usually when you have an exponent. Then we have the coefficient. The coefficient is the number in front of the variable, is the number multiplying the variable. That's the coefficient. And the coefficient includes the sign. So this is the sign. So we're going to start now talking about degree, the term or the word degree. So what is the degree of ax to the n? So if the coefficient is different than 0 and n, the exponent n is a whole number, the degree of ax to the n is n. So the exponent then is a positive number. So it's not 0. No, it can be 0 too. The exponent can be 0 or a positive integer. So the degree is going to be n. So let's just write a couple of polynomials now, or a couple of algebraic expressions to be more precise. So I'm going to write two algebraic expressions. So the first one is going to be 6x to the 4 minus 3x cubed minus 2x minus 5. So we learned from previous lessons that the pluses and the minuses are the boundaries for the different terms. So this is one term, this is the second term, this is the third term, and this is the last term of this algebraic expression. So you can see here that there are 4 terms. There are 4 terms in this algebraic expression. We don't know yet whether this algebraic expression is a polynomial or not. So we need to verify that first the different components, the different terms are going to be satisfying this definition of the degree of ax to the n. So for the first one, we have coefficient 6, and we have an exponent that is 4. So the degree of this term is going to be 4. The degree is going to be degree 4. Then we have this term with coefficient -3. The exponent is 3. So the degree of this term is 3. Then we have the next term. The coefficient is -2. The exponent is 1. Because remember, anytime that you have the variable in this way, the exponent is 1. So we're going to say that the degree of this term is 1. Finally, when you don't have a variable, when you have only the constant term, in this case the constant term is -5, then the exponent of the variable is going to be 0. So the degree of this term is 0. So what is a polynomial? So the definition that we have in your book on page 342, it says that a polynomial polynomial is a single term. A polynomial is a single term or the sum of two or more, or the sum of two or more terms containing variables with whole number exponents. With whole number exponents. So that's a polynomial. So here, when we are defining a term as the basic given on algebraic expression, but in the case when you have an exponent that is a whole number, then this term can be used to define a polynomial. So in other words, we have here four terms. Every term by itself is a polynomial. So if you have only the first term here, let's say we have only 6x to the 4, then we have a polynomial of degree 4. If you have only negative 3x to the cube, then you have a polynomial of degree 3, and so on. So negative 2x is also a polynomial of degree 1, and also negative 5 is a polynomial of degree 0. But when you have many terms, you can also have a polynomial. So a polynomial can be defined by using these four terms. So what is going to be the degree of the polynomial when you have more than one term? Then we're going to write here that the degree of the polynomial is the greatest degree, degree of all its terms, So, for example, in this case, so if we have the four terms here, so the degree of the polynomial in this case is 4, because it's the greatest degree. This exponent is the highest exponent. So that's the reason this polynomial is of degree 4. So let's check another algebraic expression. So now we're going to have the following algebraic expression: x to the 1/2 plus 2x squared plus 3x cubed. So what are the degrees of every term? So in the first case, you can find that the degree of the first term is degree 1/2. The next term has degree 2, and the last term has a degree 3. So the exponent 1/2, 2, and 3. So in this case, we have one term with a degree that is not a whole number. So because of this, the entire algebraic expression is not a polynomial. So this is not a polynomial. So we need exponents being whole numbers to have a polynomial. So we're going to start now our math. We're going to learn about operations involving polynomials. So the operations, we are familiar with the main operations in algebra. So we're going to add, subtract, multiply, and divide polynomials. So we're going to start with section 5.1. So here in your book, you have a section 5.1 on page 342 is about adding and subtracting polynomials. So let's start with that section. And we're going to work a lot of examples. This is just, you can learn this just by solving a lot of examples. So we have section 5.1 on page 342, and this is adding and subtracting polynomials. Adding and subtracting polynomials. So that is going to be the first section that we're going to cover from this chapter. So we're going to start right away, because the only rule that we're going to follow is that we need to combine. So combine like terms. That's the only rule that we need to add or subtract polynomials. So combine like terms. So we're going to start with the first example from this section. So example 1 is on page 343. So it says that we're going to add, and they are going to enclose every polynomial in parentheses just to distinguish one polynomial from the other. So I have negative 9x cubed plus 7x squared minus 5x plus 3. Then we close the first parenthesis, indicating that this is my first polynomial. Then I have another polynomial, which is going to be 13x cubed plus 2x squared minus ax minus 6, and then we close the second parenthesis. So I have two polynomials here. So the first polynomial is a 4-term polynomial. The degree is 3. In the second case, I have a 4-term polynomial too, and also the degree is 3. So our first step, we're going to remove parentheses. So we're going to apply the distributive property if needed. So here you just, since the sign in front of the first parenthesis is a positive sign, so we just remove the parentheses in this way. And then the same thing here, the sign is positive. We just write the different terms in this way. So now we have a new algebraic expression. So we're going to start combining like terms. So we're going to combine like terms. So we look for the variables at the same power. So we have x cubed here and x cubed over here. So I'm going to combine the coefficients. Remember, this is going to be negative 9 plus 13. You can indicate that in this way, negative 9 plus 13. And this is going to be for x cubed. Then I have 7 and 2. So the next one is 7 plus 2. Those are the coefficients for x squared. I'm underlining the terms that I'm using to prevent mistakes. Then I have negative 5. So the next one is negative 5 and negative a. Those are the coefficients for x. And finally I have positive 3, negative 6 for the last constant terms. So I'm going to simplify coefficients. So negative 9 and 13 is going to be just positive 4 x cubed. Then I have 7 plus 9 is just, sorry, 7 plus 2 is going to be 9. So it's going to be 9x squared. Then I have two negatives that are adding to each other. So negative 5, negative 8 is going to be negative 13, negative 13x, and finally positive 3 and negative 6 is going to be negative 3. So this is the final answer. So that's example 1. So let's work one more example. So we have example 2 on page 344. So we're going to add again two polynomials. The first one is going to be negative 9x cubed plus 7x squared minus 5x plus 3. That's the first polynomial. That's the reason of this parenthesis. The second polynomial is going to be 13x cubed plus 2x squared minus ax minus 6. So in the first example, I added the polynomials using a horizontal format and just combine every coefficient that belong to the same variable or a variable with the same degree. So now I'm going to do this by using a vertical format. So I'm going to remove the parentheses again. So we're going to remove parentheses, our first step, but I'm going to write the two polynomials in two rows. So in the first row, I'm going to write negative 9x cubed plus 7x squared minus 5x plus 3. That's the first polynomial. I'm going to do the same thing. I'm going to remove parentheses for the second polynomial, but I'm going to write every term in the corresponding column. So the first one, 13x cubed. X cubed is the first column, so I'm going to write 13x cubed. Then I have 2x squared that goes here, 2x squared, because this is the column for x squared. Then I have negative ax and negative 6. So here we're going to have the addition in a vertical format. So you just need to combine again coefficients. You work with coefficients only. So you have negative 9 and positive 13 is going to be 4x cubed. Then you have 7 plus 2 is going to be 9x squared. Then you have two negatives, so you add them up. That's 13, but since they are negatives, the answer is also negative 13x. And finally 3, positive 3 and negative 6 is going to be negative 3. So we are getting the same result as before. So we solved the same problem twice. In the first case, we did the addition horizontally. We combined the coefficients of the like terms. And in the second case, we set up the addition in a vertical format, but aligning the terms that are like terms. So the terms with the variables at the same power. So that's example 2. So that's the part that corresponds to adding polynomials. Now we're gonna work subtraction. So to get the difference of two polynomials. So when we are subtracting polynomials, so you're gonna find information about this on page 344. The only thing that you're gonna do in addition to the previous steps is you're gonna apply the distributive property when removing the parentheses. When removing parentheses. So that's We are applying the distributive property here, but the thing is that we have only one positive one in front of each parenthesis, so we just remove the parentheses and wrote the term. But when you have a subtraction, you need to apply more explicitly the distributive property. So let's go on example 3. Example 3 is on page 344. I'm going to subtract. And we have the operation indicated here. So the first polynomial is 7x squared plus 3x minus 4 minus, and then the second polynomial is 4x squared minus 6x minus 7. So I have here two polynomials, but I'm subtracting this polynomial from this polynomial. So we're going to do the same thing as before. We need to remove parentheses. Remove parentheses. To remove parentheses, we're going to write the first one the same way. So 7x squared plus 3x minus 4. And in the second case, we're going to apply the distributive property. So we're going to multiply every term inside by -1. So essentially, when you multiply by -1, when you have a minus in front of a parenthesis, so you are supposed to have number 1 here. What you do is just change the sign of every term inside of the parenthesis. Change every sign. So this 4 is positive. It's going to be now negative 4x squared. This coefficient is -6. So the opposite is going to be positive 6x. And this -7 is going to become now positive 7. So we are changing, we are switching the sign of every term inside of the parentheses. So check the signs. 4, -6, -7. Now it's going to be -4, +6, +7. So what was positive now is negative. What was negative is now positive, only for the second polynomial. So now we proceed in the same way that we did it before. So we're going to combine like terms. So we're going to combine like terms. So let's use another marker because this is, we're going to combine like terms. So this is our second step. So we're going to start with this power of x squared. We have 7 here, -4 here. So those are the coefficients for x squared. Then I'm going to use a plus always. Then I'm going to write inside of parentheses the coefficients of the next power of x. So we have 3 and +6. So those are the coefficients for x. And finally, I end up with -4, +7, the constant terms. Then we just finish simplifying this. So we're going to get 7 minus 4 is going to be 3x squared. Then 3 plus 6 is going to be 9x. And then we have here -4 plus +7. So this is going to be just +3. So that's the final answer for this example, example 3. So I'm going to work a couple of more examples, and then you're gonna have some work to do. So let's work 2 more examples. So let's see, we have example 4 on page 345. So we're gonna subtract. Now we have 2x cubed minus 6x squared minus 3x plus 9 from 7x cubed minus ax squared plus 9x minus 6. So this is the case when we need to translate partial English sentence, because it's partially English and partially algebraic, so into only algebraic. So when you have subtract something from something, the second something goes first. So you're gonna need to write 7x cubed minus ax squared plus 9x minus 6 minus, and then you write the first polynomial. This is when you have this kind of notation: subtract a polynomial from another polynomial, then this is the order in which you need to write your subtractions. So we covered this on a previous chapter. I'm just not using, you can use parentheses for the other polynomials. So again, we cross here. Okay, when you have subtract A from B or B from A, you just take care of this. Then you just need to remove parentheses. So I'm going to write 7x cubed minus ax squared plus 9x minus 6. When we remove the second parenthesis, because we have a negative sign in front of it, we just need to change the sign of every term inside. So this is positive 2, is going to become negative 2x cubed. This is negative 6, is going to become positive 6x squared. This is negative 3, is going to become positive 3x. And this positive 9 is going to become negative 9. So careful about the signs of the coefficients of the terms inside of the parentheses, the terms of the second polynomial. Now we can just combine like terms again. So you have 7 minus 2 coefficients of x cubed, 7 minus 2, then we have always a plus sign, and then the coefficients negative 8, positive 6 for x squared, and you mark these two. Then we have coefficients for x, which are 9 and 3, coefficients for x. And finally, we are ending up with negative 6, negative 9 for the constant terms. So finally, 7 minus 2 is going to be 5x cubed, negative 8 and positive 6 is going to be negative 2x squared. 9 plus 3 is 12x, and finally 2 negatives are added. So 6 and 9 is 15, but since they are negative, the addition is also negative. So this is example 4. Okay, so now example 5. So example 5, I'm gonna write here example 5 on page 345. So we're gonna subtract, and the problem is 12y cubed minus 9y squared minus 11y minus 3 minus 4y cubed minus 4y plus 8. So we have a 4-term polynomial here. We have a 3-term polynomial here. Both polynomials are of degree 3 because the highest exponent is 3. So we're going to do now the subtraction in a vertical format. So I'm going to write the first polynomial, 12y cubed minus 9y squared minus 11y minus 3. So that's the first one. Now I'm going to write the second one here, but I'm going to switch signs. I'm going to switch signs of the coefficients. Signs of coefficients. I'm going to switch signs of coefficients. So I'm going to write in the corresponding column. So I have positive. So check what is inside of the parenthesis. So we have a negative, but it's outside. So inside of the parenthesis, I have 4y cubed, which is positive 4 is going to become negative 4y cubed. Now I have negative 5y is going to become positive 5y. This goes in this column because it's y, so it's going to be positive 5y. Finally, I have the constant term 8 is going to become negative 8 because it was positive, it should be now negative. So now the last step is just we're going to combine like terms again in a vertical format. So it's just an addition again because we already switch signs. So now we treat this last operation as an addition. So we combine like terms, we combine coefficients. 12 minus 4 is going to be ay cubed. You just bring down this one, negative 9y squared. Then negative 11 plus 5 is going to be negative 6y. And finally, we have two numbers that are negative. You add them up, 11, but with negative sign. So that's addition and subtraction. It's just an application of what we learned from previous chapters. So you're going to work now 3 exercises from 5.1 exercise set. This exercise set is on what page? Let me see. This is on page 348. 348. So you're gonna work those 3 exercises. So 24. So you just perform the indicated operations. So you have a negative 7x squared plus 8x plus 3 plus 2x squared plus 8x plus 8. That's my first polynomial operation. It's just an addition to polynomials. Then we have the second one is 4x cubed plus 5x plus 13 plus negative 4x squared plus 22. So you can do this in a vertical format because you have a different number of terms. Then finally 66 is 5y cubed plus y squared minus 3y minus 8 minus, now you have a subtraction. This is the second polynomial is y squared minus ay plus 11. So again, you can do this in a vertical format because the number of terms is different. And also, remember when you write the second row, you just switch the sign of the terms inside of the parentheses. So I'm going to give you 5 to 10 minutes to do this. You can pause the video, work on this. It's better that you do it now. And then we're going to continue with 2 more operations that we do with polynomials. Now we're going to continue with section 5.2 on page 351, and it's about multiplying polynomials. So we learned how to add, how to subtract polynomials. Now we're going to multiply polynomials, and later in another section we're going to start dividing polynomials. So with that, we're going to complete the first, the main 4 operations for polynomials. So to multiply polynomials, we're going to learn some rules that are applicable to the exponent. So there are 3 rules here. I'm just wrote the 3 rules. The first one is the product rule for exponents, and is described on a green box on page 352. And it's just saying that if you have the same base, but with different powers, so we are multiplying 2 different powers of the same variable. So we are multiplying 2 different powers of the same variable. So we need to have the same base, otherwise this rule is not applicable. So when you have the same base, you just write the base, and then you add the exponents. Adding the exponents is the result of multiplying these 2 powers of v in this case. Then there is another power, the power rule for exponents, that's described on page 353. This is the case when you have a power of a variable, like for example b to the m, and you are raising that power to another power. This is a power of a power. So this is different from the case before. So this is like the exponential version of a power. So when you have a power, b to the m, for example, and you raise that to another power, for example, n, then the answer is going to be just the base, and you're going to have now the new exponent to be the product of the 2 powers, m times n. Finally, the third rule that we're going to use is the products to powers rule for exponents. That is described also on page 353. And this is when you have different factors, and all those factors are raised to the same power. So you can distribute, so to speak, you can distribute the exponent. So you can put the exponent affecting to every single factor inside of the parenthesis. So in this case, a is going to be raised to power n, and also b is going to be raised to power n. And the product continues to be in effect. So you are multiplying AB. Now you are multiplying a power of A with a power of B. So this is better understood if you practice a lot. So trying to memorize the names sometimes doesn't make any sense. So what makes sense is knowing what to do when you have these three different cases. So let's solve some problems and practice a lot, because this is going to be very important to multiply polynomials. So this first part of this subsection, this first part of this section, sorry, is about the rules that we're going to use later to multiply polynomials. So we're going to start first applying the rules, and then we're going to apply, we're going to be able to multiply polynomials. So let's start with the first example from this section. So this is going to be example 1. I'm going to write here example 1 on page 352. So we're going to multiply the following quantities. So in the first case, I have 2 to the second power multiplying 2 to the third power. So you have here powers of 2. So the base is 2. So the base here is 2. The base here is 2. So we have a common base. So we can multiply these two when you have the same base. So how do you do that? You write the common base, which is 2. So, and this is a multiplication operation. This is not raising to a power. So we are multiplying two different powers of the same base. So we're going to add the exponents. So the answer is going to be 2 to the 5th power. So that's the first case. Then we have now x to the 7 multiplying x to the 9. So what is the base here? The base is x. What is the base here? The base is also x. So we can multiply these two powers of x. So we write the common base, x, and now we're going to add the exponents. So we're going to get x to the 16th power. One more case. We have y that multiplies y to the 5th. So what is the base here? The base is y. What is the base in this other case? The base is y, so the base is the same. We can multiply those two different powers of y. And now we're going to add the exponent. So what is the exponent of the first factor? The exponent of this y is just 1. And the exponent of the second one is 5. So don't forget, if you don't have the exponent explicitly written here, you need to remember that it's 1. So finally, the answer is going to be y to the 6th power. So we have one more case for this example. So now we have y to the cube times y to the second power times y to the 5th power. So you can see that you are multiplying powers of y. So you just need to write the common base. And now you're going to add the exponents. So now we have 3 powers, then we have 3 exponents. So this is going to be y to the 10th. So that's example 1. Now we're going to have example 2. That example is on page 353. So we're going to simplify. And we have now these cases. We have now 2 to the cube to the 5th power. So now we have a power of 2 raised to another power. So this is the base. The base is 2, but this is the case where we have a power of a power. So now we write the base, but since this is a power of a power, now we're going to multiply the exponents. So when you have a power of a power, you just write 2 to the 15th in this case. So power of a power is the second rule that we have in our notes on this section. Now I have x to the 6th raised to the 4. So this is a power of a power. The base is x, and the exponents are 6 and 4. So we're going to multiply the exponent because this is a power of a power. So you need to learn to distinguish the different cases when you have a product of powers or when you have the power of a power. So here you have the product of powers of the same variable, and here you have the power of a power of a variable. So we need to distinguish the cases. So we finish this by writing x to the 24, and we have one more case. So we have a -3 to the 7, and that's raised to the 5th power. So what is the base? Here, remember, when you have a parenthesis, we are indicating that the base, in this case, is -3. So -3 is raised to the 7th power. Then that power is raised to another power, which is the 5th power. So we're gonna write the base, and we're gonna multiply the exponent. So this is gonna be -3 to the 35th power. Okay, there's one more example. So now we have example 3. Example 3 on page 354. We're gonna simplify. We're gonna simplify. In the first case, we have 5x to the 3rd power. So now this is like we have a this is the base, but this is when the base is factor. So the base is decomposing factor. So this is the base. This is still the base because this is what is raised to the 3rd power. So this is the base. The base is 5x, but you can see here that the base is composed of 2 different factors. So you can break the base. Essentially what you're gonna do in these cases, when you apply the 3rd rule, the product to powers rule for exponents, what we're gonna do is we're gonna break the base. So if you break the base, you're gonna distribute the exponent into the different parts of the base. So now we have 5 to the cube x to the cube. So the base was broken now into different bases. So one base now is 5 to the 3rd, the other base is x to the 3rd too. So we are breaking the base in some sense. So we are breaking a base that is written in a factor form. So that's the application for the 3rd rule. And in this case, when you have numbers, powers of numbers, you can simplify by rewriting the exponential expression, exponential notation into a multiplication form. So when you have 5 to the 3rd power, this is equivalent to writing 5 times 5 times 5. That's the definition of this exponential expression, that the base is multiplied by itself, the number of times that indicates the exponent. And this is non-numerical, the variable remains. So only when you have numbers raised to a power, sometimes you're going to need to simplify this. So 5 times 5 times 5 is going to be 125x cubed. Okay, so now there are more case for this example. So we have now, the next part is -2 y to the 4, and this is going to be raised to the 5th power. So again, my base here, the base is -2y. So we can break the base in two parts again, the numerical part and the variable part. So we're going to do this in this way. So we're going to distribute again the exponent. So one part is going to affect this part, and the other part is going to affect this part, and I'm missing something. The base is everything inside of the parentheses. So let's distribute the exponent. So the first part is just -2. Now it's going to be to the 5th power. And the other part of the base is y to the 4. And that is going to be also raised to the 5th power. So finally, the first part, the numerical part, is going to be -2 times -2 times -2 times -2 times -2 5 times, because the exponent is 5. Then y, and in this case, this is a power of a power. This is going to be 4 times 5. So the final answer is going to be, in this case, we have 1, 2, 3, 4, 5 negative factors. So 5 negative is an odd number of factors, so the answer is going to be negative. Then 2 times 2 times 2 times 2 times 2 is going to be 32. And finally, y is going to be, we're going to raise y to the 20th power. So that is the answer for this example. Now I'm going to give you 4 problems to work on. So this is in preparation for multiplication of polynomials. So we are not multiplying polynomials yet. So we just learn about the rules of exponents that we're going to need to know to be able to perform polynomial multiplication. So to be ready for that, you're going to need to work on the following set of problems. So you're going to just simplify everything that is given here. So you have x to the 4 times x to the 3rd times x to the 5th. Then you have problem 12 is just x to the 12 to the 4th power. Then you have problem 20 plus 6x to the cube to the 2nd power. And finally, 24 is just -2x to the 11th power, and everything to the 5th power. So you're going to have 10 more minutes to work on these 4 exercises. You need to work on all of them. This is important. And then we're going to start multiplying polynomials. So before starting the next part of this section, it is important to know some terminology, because I'm going to be using that terminology from now on. So anytime that I say or refer to a monomial, what I mean is a polynomial with one term. So monomials are polynomials with one term. So anytime that I talk about a binomial, what I'm talking about is a polynomial with 2 terms. Finally, if I say a trinomial, what I mean is a polynomial with 3 terms. So monomials, binomials, and trinomials are going to be used a lot in, that's the terminology I'm going to be using a lot from now on. So to multiply polynomials, which you can find a description on page 354, we only follow two steps. We multiply coefficients on one hand, and we multiply the variables on the other hand. So let's start with one example. So I have example 4. Example 4 on page 355. And it's important to know that these rules apply for monomials only. So you multiply the coefficients and you multiply the variables. So example 4 is going to be then a case where we are multiplying monomials. So let's start. I have, for example, 2x multiplying 4x squared. So you have here two monomials. So this is a polynomial with one term, and this is another polynomial with only one term, and I'm multiplying two polynomials, in this case, two monomials. So we're gonna follow these rules. We're gonna multiply the coefficients. So what are the coefficients? 2 and 4. So I'm going to write here 2 that multiplies 4. And then I'm going to multiply the variables. So in the first case, I have x. Then in the second case, I have x squared. So here, this is the first part. We are multiplying coefficients. And this is the second part. We are multiplying the variables. Then we proceed using the rules that we learned before for exponents. So in the case of coefficients, it's just a simple multiplication. 2 times 4 is going to be 8. But in the case of the variables, we're going to use the rule for exponents, in this case for product. So we're going to have here the product of the variable at different powers. So in this case, you're just going to add the exponents. So the final answer is going to be ax cubed. So this is the result for the first case. Let's work on one more case where we're going to multiply monomials. So I have negative 10x to the 6 multiplying 6x to the 10. So first we multiply coefficients. So coefficients are negative 10 and positive 6. This is the first part. The second part, we multiply variables x to the 6 and x to the 10. This is the second step. And then we simplify. So this is going to be negative 60. And then you're going to have x to the, and you add the exponents. 6 and 10 is 16. So that's the answer. So now we're going to extend our knowledge to involve now binomials or any other polynomial. So the next thing that we're going to do is we're going to multiply. We're going to be multiplying a monomial and a polynomial. So we're going to multiply a monomial and a binomial, a monomial and a trinomial, and so on. So what are going to be the rules? In this case, you're going to apply the distributive property first. So you're going to get a set of products of monomials. So you're going to multiply every pair of monomials, that resulted from the previous step. So that after applying the distributive property, we're going to end up with a series of multiplication of monomials. So let's work one example. So we're going to work example 5. Let's do that in the next page. So we have example 5 on page 355. So we're going to multiply, in the first case, is just 2x and x plus 4. So we have here a monomial. This is a monomial, and this is a binomial. So the first thing that we're going to do is we're going to apply the distributive property. So we have 2x, and we're going to enclose 2x to see that this is my monomial, and x plus 4 is my binomial, and I'm going to apply the distributive property. So this monomial is going to multiply x, and then it's going to multiply 4. So that's the distributive property. So what I'm going to get is 2x multiplying x plus 2x multiplying 4. So now I have the multiplication of two monomials here and the multiplication of two monomials here too. So we transform a problem where we were multiplying a monomial and a binomial now in a series of monomial multiplication. So let's work now on this. So here we multiply coefficients. So 2 times 1 is going to be 2. And then we have x times x is going to be x to the second power. Plus coefficients. 2 times 4 is going to be 8. And x is only appearing on the first monomial. So it's just x. That's part A. Part B, we have now this monomial multiplying this trinomial. So we have 3x squared multiplying 4x cubed minus 5x plus 2. So we're going to multiply 3x on the first term, then on the second term, and finally on the third term. So let's write this down carefully. So we have 3x squared that multiplies 4x cubed. Then again, 3x squared now multiplying minus 5x, and then 3x squared multiplying 2. So we apply the distributive property. Now we're gonna need to multiply every pair of monomials. So coefficients first, 3 times 4 is going to be 12. X squared times x cubed, you're going to add exponents. So this is going to be 5. Then coefficients 3 times negative 5 is going to be negative 15, because positive times negative is going to be negative. Now x squared multiplying x, you're going to add exponents. 2 and 1 is going to be 3. Finally, 3 times 2 is going to be positive 6. And x squared stays by itself because there is no other x over here. So that's the final answer for this example. So you're gonna work now a set of problems. The exercise set. This is 5.2 exercise set on page 359. So you're gonna multiply the following problem. So we have 28. You just multiply 10x and 3x squared. And then we have 34. You're going to multiply 3x cubed and negative 2x and 5x to the 6. Then we have problem 36. You multiply 6x and x plus 5. Then 46. You multiply 4y squared and y squared plus 2y. And finally 54. You're going to multiply negative 6x squared and 3x squared minus 2x minus 7. So you're going to have 15 minutes to work on these 5 problems. This is required because we are entering the part of math where everything counts now. It's very important for you to know how to multiply polynomials. Now we're going to multiply polynomials when either of those polynomials is a monomial. So I'm going to show you a general method. It's not in your book. That's the way I do it. That's the way that I have simplified my life when I was a student. So first you're going to write one of the 2 polynomials vertically. Then you're going to multiply every term of the vertical polynomial by the other polynomial. And finally, you're going to apply the distributive property in every case, and you're going to simplify. So this is going to be a sort of general method. So this is a general method to multiply polynomials. But we're going to have a shortcuts. So there are special cases. So there are special products, and those are covered on section in section 5.3. So we're going to cover that section in a minute, and with that we're going to finish our lecture today. So I'm going to solve use a couple of problems. I'm going to solve 3 problems on how I multiply polynomials when they are not monomials. So let me just start with example 6. This is on page example 6 on page 356. So we're gonna multiply. In the first case. We have used x plus 3 that multiplies x plus 2. So these are two binomials. Two binomials. So there are going to be a short way to do this work later when we cover the next section. But it is good to know the general method, because if you forget how to use a special form, or if you forget your formula sheet, or you simply want to learn just one method for everything, this is the method. So we're going to write one of the two polynomials vertically. You can choose the first one or the second one. It doesn't matter. The answer is going to be the same. So I'm going to write vertically the first one. So I'm going to write x plus 3. So that's the first polynomial written in a vertical format. And then I'm going to multiply each of those terms by the other polynomial. So the other polynomial is x plus 2, x plus 2. And then we proceed with the corresponding multiplications, applying the distributive property. So you're going to apply the distributive property here. So you're going to multiply this monomial by this binomial. So you're going to get just x that multiplies x plus x that multiplies 2. And you're going to do the same thing with the other monomial and binomial. So you multiply 3 and the terms of the binomial. So you're going to have 3 times x and plus 3 times 2. I indicated the operations. Most of the time you don't need to indicate the operations. You write away the answer. So in this case, once you have mastered this in your mind, you don't need to write it. You just go x times x is going to be x squared. And x times 2 is going to be 2x. We don't write x2. We write 2x because you need to write always first the coefficient and then the variable. And the same thing here. 3 times x is going to be 3x. And 3 times 2 is going to be 6. And again, you can skip this step. So you're going from 3 times x directly to here. 3 times 2 equal to 6 here. And then you're going to write this. You're going to combine this. The way that you can do to combine this is you can write this in a horizontal way, or you can just look for common or like terms. Usually when you are multiplying polynomials in these ways, you end up with common terms that are not aligned vertically, but they are aligned diagonally. Is something that I have been observing for a long time. So for many years, I realized that when I finish this part, I have my terms aligned in a diagonal way. So you can see here that these two terms are like terms. So I'm going to write x squared. There is nothing that in the diagonal. You don't work in this way. So I'm talking the diagonal in this way with a positive slope. So I have x squared plus 2 plus 3 is going to be 5x plus 6. So that is going to be the answer for this example 6. I'm going to work now example 7. Let's see, example 7 is on page 357. So we're gonna multiply, and we have 2x plus 3 multiplying x squared plus 4x plus 5. So again, I'm going to write one of the polynomials vertically. So I'm going to write 2x plus 3, and I'm going to multiply every term by the second polynomial. And then we're going to apply the distributive property. So we're going to multiply this, this, and this. this, and this. So this is the distributive property. So now you can do everything in a single step. So let's start. Coefficients, 2 times 1 is 2. Variables, x times x squared is going to be x to the cube because 1 plus 2 is 3. Now, next set of coefficients, 2 times 4 is going to be 8. Variables, x times x is going to be x to the second power because 1 plus 1 is 2. And then 2 times 5, so coefficients is 10. Variables, you have only x here, no x's here, so you end up with 1x. Now the second row, coefficients, 3 times 1 is going to be 3. Variables, you have only x squared inside, no variable outside. Again, coefficients, 3 times 4 is going to be 12, and x only inside. Finally, 3 times 5 is going to be 15. So now we're going to work like terms. Again, you can see here that the terms are aligned in a diagonal way. The like terms are aligned diagonally. So we take advantage of that. So 2x cubed, there is no another power of x, a third power of x is the only one. Then we have this diagonal a plus 3 is going to be 11 x squared. Then again, we combine coefficients. 12 plus 10 is going to be 22 on x. And finally, 15. So that's example 7. Let's work one more example, and then you're going to have work to do. So this is example A on page 357. So now we're going to multiply. We're going to multiply 2x squared minus 3x and 5x cubed minus 4x squared plus 7x plus 7x. You can do, you can write the first polynomial vertically. I'm going to write now the second one vertically, and for you to see that you can get the same answer. So I'm going to write the second polynomial vertically. So 5x cubed minus 4x squared plus 7x that multiplies now the first polynomial. So I'm going to write that polynomial 3 times, 2x squared minus 3x, and then I'm going to apply the distributive property for every case in every row. So let's start. Coefficients, 5 times 2 is going to be 10. X to the 3 plus 2 is going to be 5. So 10x to the 5th power. Then positive 5 times negative 3 is going to be negative 15. X to the 3 plus 1 is going to be 4. The next row now, negative 4 times positive 2 is going to be negative 8. Now x squared times x squared is going to be x to the 4 because 2 plus 2 is going to be 4. Negative times negative is going to be positive. 4 times 3 is going to be 12. And x is going to be to the 3rd power because 2 plus 1 is going to be 3. Finally, the last row, positive 7 times 2 is going to be 14. Then x times x squared is going to be x to the cube because 1 plus 2 is 3. And finally, positive times negative is negative. 7 times 3 is going to be 21x to the 2nd power because 1 plus 1 is going to be 2. Now we're going to simplify this. And again, we're going to check diagonals. So you can see here that this negative 15 and this negative 8 are going to work together. And then the same thing for 12x cubed and 14x cubed. So I have my diagonals identified. So now I can simplify. I start with 10x to the 5th. Then I'm going to combine x to the 4. So negative 8, negative 15. So you combine two negative numbers. So you add the absolute values, you get 23. But since they are negative, this is going to be negative 23 x to the 4 because we are adding the 4th power of x. Now the next diagonal, we have 12 plus 14 is going to be 26 x cubed, and finally negative 21 x squared. So that's the final answer. So now you're going to work 5.2 exercise set on page 359. So problem 56 is x plus 4 multiplying x plus 6. Then problem 64 is 3x minus 4 multiplying x plus 5. So 68 is x plus 2 multiplying x squared plus x plus 5. Then we have 74 is x plus 1 multiplying x cubed plus 4x squared plus 7x plus 3. And finally 78 is just x squared plus 3x plus 1 multiplying x squared minus 2x minus 1. So at least we're on problems 64 and 74. And then we have one more section to finish our lecture today. It's about special products or shortcuts to multiply polynomials. So we're going to start section 5.3. That's the last section that we're going to cover for our today lecture. So section 5.3 is about special products. This section starts on page 361, and special products are just shortcuts to multiply polynomials. So, and the most important formulas start at page 363. So there is first a method that is used to taught at high school, which is the FOIL method. So the FOIL method is just FOIL is just a word that helps us remember the order in which we're going to multiply every term. So we're going to start with first terms, that with outside terms, inside terms, and finally last terms. If we multiply first terms first, we're going to get A times D. So this method is only for binomials. Sorry, A times E. Those are the first terms. Then we multiply outside terms. So we're going to multiply this and this. So we're going to get A times D. Then we multiply inside terms. That's B times C. And finally, we're going to multiply last terms. The last terms are just B and D. So you need to memorize this. Otherwise, just follow the rule that we, or the method that we learned in the last section. You write vertically one of these two, and you proceed applying the distributive property. So that's one method. There are other special cases when you are multiplying two binomials, and the binomials have the same first and second terms, with the difference that the second term only has opposite sign. So when you have this kind of binomials, you can say these binomials are conjugate. So A plus B is a conjugate of A minus B. So the first term is the same, the second term is almost the same. The only difference is the sign. So these are known as conjugate binomials. So when you have conjugates, the rule is very simple. You just square the first term, you square the second term, and you write the difference on both. So that is going to be the formula to remember. This is a very, very helpful formula. Also, there is another formula when you are squaring a binomial. So A plus B squared. When you square the binomial, you just need to square again the first and the last, but you put in between the double product of A and B, so the double product of the two terms. And if you have the binomial where the second term is a -1, then you just need to write the middle term negative in the formula. So we're going to apply these shortcuts, but remember, if you forget this, just follow the general method that I described in the previous section. So we're going to start with example 3. Example 3 is on page 363. So we're going to multiply. We're going to multiply 2 minus 5x and 3 minus 4x by using the FOIL method. So we're going to use the FOIL method. So we're going to start with first terms. So first, these are the first terms. So it's going to be 2 times 3. Then we go with the outside terms. So the outside terms are these and these. So these are the outside terms. So coefficients, 2 times -4 is going to be, I'm going to write first, use the indicated operation. Then we're going to proceed with the simplification. So then inside terms are these two. These are the inside terms. So this is going to be -5x that multiplies 3, and finally the last term. So the last terms are these. So the last terms are these are not the last terms. This is the last term. So this is not the last term. The last terms are these two. These are the last terms. So it's going to be -5 x times -4x. So -5x times -4x. So let's simplify this. This is going to be just 6. This is going to be -2. So we have, in the next case, we have 2 times -4 is going to be -ax. Then we have -5 times 3 is going to be -15x. And finally, negative times negative is going to be positive. 5 times 4 is going to be 20x squared. Then you just combine like terms. We have two terms that are like. So it's going to be 6 minus 23x plus 20x squared. So this is the FOIL method. Maybe I show the FOIL method in a very terrible way because I don't use the method, so I try to, we're messing up the term, but yeah, you understand the idea. The idea is that you need to memorize the word FOIL and the meaning of every letter of that word, And that is going to be the order in which you're going to multiply the terms of the two binomials. If you don't like it, just use the general method. So we're going to go now example 4. Example 4. Page 363. So we're going to multiply again binomials. So the first one is just 4y plus 3 times 4y minus 3. And you check the first and the second binomial, and you see that the first term of each are the same, and the second term of each is just differing from the sign only. So they have a different sign. So this is like having a plus b, and here a minus b. So the formula is very simple. We're going to find a squared minus b squared. So what is a? Is 4y. Minus what is b? B is 3. So I'm going to square that. So the final answer is just 16y squared minus 9. Okay, let's work one more case. Now we're going to multiply 3x minus 7 and 3x plus 7. So you can see here that this is again the same case. We have conjugates. So one is a and the other is b. So we only need to find a squared minus b squared. So this is going to be 9x squared minus 49. So this formula is beautiful. So definitely simplify our lives. So the final problem is 5a to the 4 plus 6 and 5a to the 4 minus 6. So again, we have two binomials that are conjugates. So this is a, this is b. So we're going to square a. So 5a to the 4 is going to be squared. Minus 6 is going to be squared. So 5a to the 4. So you distribute the exponents. So we know this rule. So it's going to be 5 squared, and a is going to be to the 8th power, and minus 36. So the final answer is just 25a to the 8th power minus 36. We're going to end up with two more problems. We're going to work now example 5. So on example 6, and then you're going to be able to work on some exercises to complete the classwork for this, corresponding to this lecture. So we have now example 5. Example 5 on page 364. We will multiply, and we are given x plus 3 square. So when you have the square, and remember this is equivalent to x plus 3 times x plus 3. If you don't remember the formula, rewrite this as the product of this binomial multiplied by itself, because that's square. That's the meaning of this exponent. X plus 3 multiplying x plus 3, and you solve this using the general method or using the FOIL method. But if you remember or you have your formula sheet, you know that you can use the formula for a plus b squared, which is just the square of the first the square of the last, and in between we use to get the double product of the double product of the terms, of the two terms. So this is going to be just a is x squared plus 2 times the first, which is x, times the second, which is 3. And finally, the square of the second is 3 squared. So we simplify this as x squared plus 2 times 3 is going to be 6x plus 3 times 3 is going to be 9. So that's the final answer for problem. If you don't know, if you don't remember this, just solve the problem by using this expression. So finally, example 6. Example 6 on page 365. So we're gonna multiply, and now we have 5y minus 6 squared. So we're gonna solve now that problem. Now we have a binomial where we have the difference of two terms. So let's identify A, identify B. So we know that A minus B is again the square of the first and the last, but now we're gonna subtract the double product of the first and the second terms. So that's the formula. So we have A is 5y, we're gonna square that, minus now 2 times the first term, which is 5y, the second term is 6. So you don't use negative 6 because you already have taken into account the sign here. So don't be confused, don't write negative 6 here. And then plus the second one is just 6 squared. So we're gonna write 25y squared because we square 5, we square y. So we are breaking the base. Minus 2 times, so 2 times 5 is 10, times 6 is going to be 60. Y, don't forget the variables, inspect carefully your products, don't miss variables. And finally, 36 here. So that's all with respect to special products, shortcuts. So the problems I'm going to give you as an assignment should be solved by using the special products, so that, yeah, if you don't want to learn this, just use the general method. But yeah, the purpose of these problems is for you to identify those special cases and use the corresponding formulas. So we have problem 12 is your 4y minus 5 times 7y minus 4. Then problem 18 is 7x squared minus 2 times 3x squared minus 5. Then 28, 2x plus 5, 2x minus 5. 38 is y squared plus 2, y squared minus 2. 48 is 5x plus 2 squared. And finally, 56 is 9 minus 5x squared. So at least work these 4 problems. So this is the end of this lecture. So collect all your work. Now is the time for you to take screenshots of all your work throughout this lecture, and then compile and get just a single PDF file by using your app of preference and submit that file. If you have questions, you send me an email and include a screenshot of your solution to see where you are maybe making some minor mistakes or misunderstanding something. So that's the purpose of this lecture, and that's the purpose of classwork, to identify where you need to work more. And then and also include the number of the program and number of the page. We're going to continue with more polynomial math the next time.